right, so today we're going to talk about polynomials. So polynomials are the sum or the difference between two or more terms. We're going to see some parentheses here in a little bit to separate our terms. First, before we get into that, we need to cover combining like terms. So right now, I have two x's here. They are like terms because they are the exact same variable. So if I have an x plus an x, I'm going to add those together to give me 2x. The way I know that I have one of each is because there's always a coefficient of 1 that's invisible when you just have a single variable. Otherwise, like on our next problem, you're going to see a number in front of that variable telling you how many x's there are being multiplied together. So here I have 2x plus 3x. So what I'm going to do is add my coefficient, that number in the front of the x's, together, giving me 5. And then I'm just going to keep my x because, again, they were just like terms and all we're doing is adding them together. Here I have 4x squared plus 4x. Now, kind of like the last two that we just saw, we see that we have x again. However, the one on the left side has x squared. That means that's 4 times x, unlike the right one that says 4 times x. Since they are the same variable but have different exponents, they're actually not going to be like terms. So this is as simple as we can make this expression because there's no combining to be done. Here, however, we have 5x squared plus x squared. They do have the same variable and the same exponent. Therefore, we can add them together. So if I take 5 and add it to the coefficient of 1, that's where I'm seeing my x squared. It has a 1 in front of it. I'm just going to do 5 plus 1 to give me 6. The x squared, since it's just being added, just the coefficients, is going to stay the same. So I will have 6x squared. Now that we've done a little bit review of combining like terms, let's go ahead and try a polynomial. So luckily with adding polynomials, there really isn't a lot of variation aside from you have extra parentheses and you have a plus in the center. The good news is you're just going to add your like terms together. Also, just as a reminder, since we haven't actually seen this in this presentation so far, is that whatever sign's in front of that number goes with that number. So if you have a positive sign or a plus sign in front of a number, that makes it positive. If you have a minus sign or a negative sign in front of a number, that's what makes it negative. So really, you can treat it as subtraction once we get there, but make sure you know what sign goes with what number. So let's go ahead and look at this. We want to combine like terms. So let's identify what those like terms are. Our first one, we have 3x to the fourth, and I also see 6x to the fourth. So if I do 3x to the fourth plus 6x to the fourth, I'm going to get 9x to the fourth. All I did was added my 3 and my 6 together to get 9, and x to the fourth remains the same. Next, I'll look at that negative 5x squared. There was a minus in front of that, which makes that negative 5. And I'm adding it with plus 2x squared, which you might notice that's a positive 2x because it has a plus in front of it. So when I combine negative 5 and positive 2, I'm going to get negative 3. I need to include my x squared on here because that's what made them like terms. Lastly, we have a 1 and we have a minus or a negative 7. So I'm going to add 1 plus negative 7 to give me negative 6. At this point, this is our simplified expression. It's not going to get any smaller than this because there's nothing else left to combine that is like terms. All right, let's try our second one. Remember, we're going to combine like terms with this one. So we have r squared plus 2r minus 3 plus 3r squared minus r minus 1. So we're going to focus on the r squared plus the 3r squared first. These are both positive. Neither of them have a sign in front of them that's indicating that they are negative. So again, that first r squared is a 1r squared. So we're going to just do 1 plus 3 to give us 4r squared. Next, we're going to look at the 2r and also that minus r, which is also like a negative 1. So if I think of 2r plus a negative 1, that is going to give me plus 1r, or just plus r. And then lastly, we have negative 3 plus negative 1. Now these are both negative numbers, so it's really important to remember when you have the same sign and you're adding, that you add and then keep the sign. So negative 3 plus negative 1 is going to give me negative 4. At this point, our problem has been simplified and we are finished because there's no other like terms that can be combined. Okay, let's go ahead and try another addition one. So we have combined like terms again. That's what you're doing every single time. Let that sink in. So our first like terms are, well, actually this time, there's only one. So we have negative 2a to the 5th. If you notice, there's nothing else with that a to the 5th. Therefore, that one's just going to come down as negative 2a to the 5th. There's nothing you need to do there. Besides, make sure you keep your sign. It's really, really important that you remember to do that. Let's go ahead and look at negative 2a to the 4th plus a positive 6a to the 4th. So remember, that minus in front of that 2 makes it negative. So negative 2 plus 6 is going to give us positive 4a to the 4th. When I add a negative 2 and 6, I get positive 4. Next, we're going to look at that positive 2a squared, which also doesn't look like it has any buddies with it. There's nothing else that has like terms with this one. So we're just going to add this one as 2a to the second power, just how we did the negative 2a to the 5th power. Lastly, we do have two more that can be combined. We have 7a plus, and that's a negative 2a. So when I do 7 plus negative 2, I'm going to get a positive 5a. At this point, there's nothing else that can be combined, therefore we are done. Now sometimes when you're using a polynomial, you're going to have a minus in between. So we're actually going to be subtracting or taking away from the first part. So this one has one extra step. It's going to be almost the same type of problem as far as combined like terms, but with one extra step at the beginning. So what we're going to do this time is we're going to distribute the negative, which means by doing so, it's going to actually change all of our signs. The way you want to think about this one is you're going to be giving the negative sign to each term in the second part of your problem. So everything in the parentheses, because it's following that negative, you're subtracting all of that. So that negative 2c to the 5th is now minus negative 2c to the 5th. That plus 6c is now minus positive 6c. And then we have our negative 1, which is now subtracting negative 1. So if we think about how that looks, that's actually going to just flip-flop all the signs in the second part of the problem. So once we've done that, we're pretty much using keep, change, change. The whole first part of the problem is going to stay exactly the same. It's kept. Nothing changes on that one. The minus now becomes a plus, and then everything else in those parentheses, if you take a look, have become the exact opposite of what they were before. So my negative 2c to the 5th became a positive 2c to the 5th because it was minus negative. My 6c, which was positive before, is now minus 6c or negative 6c because I had minus a positive. And lastly, when I had negative 1, that became minus negative 1, which becomes a positive 1 or a plus 1. So now that we've changed that, we're going to just solve it just like we did our other ones. So we're going to start with negative c to the 5th and add it to 2c to the 5th. So that's negative 1 plus 2, giving us positive c to the 5th. Then we have 8c plus, now it's negative 6c. So remember, we changed our signs. 8c plus negative 6c is going to give us a positive 2c. And lastly, we have a positive 2 plus a positive 1, which will give us a positive 3. It's really important to use keep, change, change when you're using this. Or you can use the distributive property, saying that there's a -1 on the outside and I have to multiply all those terms on the inside of the parentheses. Either way you do it, it will work. As long as you change all of your signs. That's the main part about distributing a negative polynomial. Well, thank you for tuning in today. I hope that you learned something. These can be kind of complicated, but once you get them down, they're actually not too bad. Have a great day.